Bismillahirrahmanirrahim. This video is also from Mr. Hayt's book, Practice Problem 8.6. And this is also on the request of same student from Singapore. So let's see, this is the question, circuit given, and we have to find VC, that is the voltage across the capacitor, and VO, voltage across the output resistance, at three different times, at time t0 minus, at time t0 plus, and at time 1.3 millisecond. What I have done is I have divided this into different parts. Part A, this one, I'm writing it part A1 and A2. In part A1, I'll find VC, and part A2 will find VO, and similarly the other two. So let's find the first part, VC0. Now at time less than 0, this switch is closed because this is opening at t is equal to 0. So our circuit will now be, the switch is closed. Also, since this switch is closed for a long time, therefore we assume that the capacitor has been fully charged and it now will behave like an open circuit. So the capacitor is open circuit. And now we can find the voltage across this, which will be the same voltage that is across 1250. So we'll use this source, and on solving the left hand side, we can find VC 0 minus. So VC 0 minus is actually VR 1250, and VR 1250 can be found from total voltage divided by total resistance multiplied by the resistance across which we want to find. So by VDR, the answer will be 100 volt. So VC0 is 100 volt, and I'm just going to show the answer given in the book and tick each one as we go on. The first one is done. Now the next is to find VO0. Now at VO0 again the circuit remains closed, and this side will now solve to find VO0. And for ease, I'm naming this node as V1. So we can calculate V1 and then find V0. Now these two can be added, 500, and then we'll solve them in parallel. So it will be 400, 2 kilo and 500 in parallel will be 400. I hope you can do it, solve it. And now from this circuit, we can easily find V1 by voltage division rule. So 120 divided by 600, 400 multiplied by 400. So 48 volt is V1, but we need to find VO. So again, we voltage divide this one we know, so dividing and multiplying by 400. So V1 divided by 100 plus 400 multiplied by 400 is 48, and solving we get it 38.4 volt, and this is the answer. This one ticked. Coming on to part B1, we have to now find VC0 plus. This concept you have to be clear here. Now if this is the circuit, let's say the input we are applying a step function here, but the inductor or the capacitor will not charge instantaneously. They take some time. And so there is a rule that if this is the point 0, then the capacitor voltage at this time 0 plus will be same as the capacitor voltage as 0 minus. And similarly inductor current. So since we are dealing with the capacitor, we'll now remember this, that the capacitor voltage does not change instantaneously. And what was the capacitor voltage that we had found? Okay, let me see. Okay. Open this, and then this capacitor voltage we had found to be 100 volt, VC0 minus. So it will be same as VC0 plus. So VC0 plus and is equal to VC0 minus and is equal to 100 volt. So part B1 is done, and we take the third part, and then again the right hand side, similar technique. Now that the switch is open, we can treat this to be the source present. So we'll treat that as a source. For ease, we are removing this and naming this node as V1 because we have to find voltage here. So simple, again, same techniques, adding these two, then solving in parallel, and then by voltage division rule, we can find VA. 100 volt will be here and same 100 volt will be here. So from here, VA is by voltage division rule, 100 divided by these three multiplied by 400, 32 volt. And now we need to find this voltage. So we go here, VA we have found 32. We divide by these two and multiply by 400. Voltage division rule. So 32 divided by these values. The answer is 25.6 volt. So this is the fourth part. And now the last two parts. We have to find VC at 1.3 milliseconds. Now we are in the transient condition, so the capacitor will be there at t greater than 0. For any time t, we should be solving the question in transient period, where the capacitor will not be open circuit and the inductor will not be short circuit. Okay. And which type of circuit is this? There is no source present in this. So this will be called source-free circuit. And I hope you remember that for source-free circuit, we use this equation to find voltage, where V0 is actually V0 plus or V0 minus. Just for ease, this VC I'm writing VCT. Okay, so V0 is V0 plus, also equal to V0 minus, which we have found to be 100 volt. So this is 100 volt. So our VCT is now 100 e raised to the power t over Req. Now Req we have to find R equivalent from this circuit. We just, again, same technique, adding, solving in parallel, and solving, we got to find the total resistance. So these two solved 400, these two added 850, and now these two in parallel. So this is solved 1250, parallel 1250. So the net will be half of it, that is 625 ohm. So this is our R equivalent. R equivalent need to C is 625 and C is 4 microfarad. So the answer will be 1 over 400 seconds. And now we plug into the VC equation, and simplifying, it will be 100 e raised to the power minus 400 t. Now this is VCT. Now we have to find actually for 1.3 milliseconds. So for t, we'll put 1.3 milliseconds. So VC 1.3 millisecond is 100 e raised to the power minus 400, and this is the 1.3 millisecond. Solving, we find answer to be 59.5 volt. And this is the answer given in the book. So this done, and the last part is again VO 1.3. The easiest way is to find is that we already know this voltage to be 59.5 from here. From previous slide we calculated this. So we'll use this as a source to find this voltage here. Technique remains same. This and this parallel 400, these two added. We need to find V1 from this circuit. 59.5 is applicable here and also applicable to this part. So V1 will be 59.5 divided by these two multiplied by 400, 19.04. And then from here we will find V0. So V0 is now V1 divided by these two multiplied by 400. V1 we already know is 19.4. So solving, we get the answer 15.23 volt. And this is also correct. 15.22 or 23 is the same thing. So I hope you have been able to follow this. Please let me know through your comments. And don't forget to share and subscribe. Thank you.